Okay, so we are going to focus on simplifying rational expressions and multiplying and dividing rational expressions. So in order to simplify a rational expression, you have to be able to simplify out a factor that's in the top and the bottom, so in the numerator and the denominator. So here I have 3y times y plus 7 over y plus 7 times y squared minus 9. So a factor has to be present in the numerator and the denominator. Well, there is a y plus 7 in both the top and the bottom, so I can eliminate that factor. So now in the numerator, I'm left with 3y over, in the denominator, I always make sure to see if I can factor further. And y squared minus 9 factors down to be y plus 3, y minus 3. So now double check. Are there any factors present in the numerator and the denominator that are in common that I can get rid of? No, there's nothing else in common, so I've simplified completely. So I get 3y over y plus 3 times y minus 7, or you can say it's 3y over y squared minus 9. Okay, under what conditions is the expression 3y times y plus 7 over y plus 7 times y squared minus 9 undefined? What that means is what values, if you were to plug in for y, would make the denominator 0. Now, I like to write everything in the factored form. So my denominator, so I can rewrite it as 3y times y plus 7 over, I've got y plus 7, and then y squared minus 9, I can write as y plus 3, y minus 3. You always go back to your original. So I haven't changed anything. I haven't eliminated any factors, so I can use my factored form right here. But I'm going to look at my denominator and see what values, if I plugged in for y, would make the denominator 0. So y cannot equal negative 7. Because if I were to plug in negative 7 for y, I would do negative 7 plus 7, which is 0. And then it doesn't matter what anything else is. When you multiply by 0, it gets 0. So y can't equal negative 7. Y also can't equal negative 3, because negative 3 plus 3 would be 0. And then y also can't equal a positive 3, because if I plug in positive 3 right there, 3 minus 3 is 0. So I have 3 values that would make my expression undefined. So you just look to see what could you plug in for y that would make your denominator equal 0. So I'm going to simplify x times x plus 5 over x plus 5 times x squared minus 16. I have an x plus 5 in the top and the bottom, so I can knock those off or simplify them out. So I get x over, now I'm going to see if my denominator can simplify. So x squared minus 16 simplifies to be x plus 4, x minus 4. That's just factored. And now double check, do I have any factors in common in the numerator and the denominator? I do not. So I can say that my answer is x over x plus 4, x minus 4, or x over x squared minus 16. So it would be B. Under what conditions is the expression x times x plus 5 over y plus 5 times x squared minus 16 undefined? So you're going to look and see this should actually be an x plus 5, not a y. So you're going to look and see what values, if I were to plug into the denominator, would make the denominator 0. So my denominator is x plus 5, and then x squared minus 16 is x plus 4, x minus 4. So all I'm looking at is the denominator. I don't really care about the numerator right now. So x cannot equal, well, with the way it's stated, what conditions make it undefined? So the x values that make it undefined are x equals negative 5. So if I plug in negative 5 here, negative 5 plus 5 is 0. X equals negative 4. Because if I plug in negative 4 plus 4 is 0. And then x equals positive 4, because positive 4 minus 4 is 0. So I've got 3 undefined values, negative 5, 4, and negative 4. for what value or values of p is p squared plus 2p minus 3 over p squared minus 2p minus 15 undefined. Now, all I care about is what values make it undefined. So I don't care about the numerator, so I can just look at the denominator and factor it. So factors of negative 15 that add up to negative 2 are negative 5 and positive 3. So that would be p minus 5, p plus 3. And seeing what makes it undefined, that would be positive 5 and negative 3. Okay, so what values of p is undefined for p squared plus 5p plus 6 over p squared plus 8p plus 15? I'm only looking at what values make it undefined, so I don't care about the numerator. I'm only looking at the denominator. So factors of 15 that add up to positive 8 are 5 and 3. So it's p plus 5, p plus 3. And then, so my undefined values would be negative 5 and negative 3. So I don't care about the numerator at all when I'm looking for undefined values. I'm only looking at the denominator. Okay, we're going to simplify a to the fourth b minus 2a to the fourth over 2a cubed minus a cubed b. So I'm going to factor. So in my numerator, I can factor out an a to the fourth power, and I'm left with b minus 2. Over in the denominator, I can factor out an a cubed, and I'm left with 2 minus b. So factors that I have in common in the numerator and the denominator is I've got an a to the fourth on top and an a cubed on bottom. So I can simplify that and just have an a on the top. And then I've got b minus 2 over, so this is gone, and this becomes a 1. So in the denominator, I'm going to rearrange it and write the b in the front. So my denominator is negative b plus 2. Now, looking at my numerator and my denominator, they are very, very similar, except for the fact that the b's are opposite signs. The one's positive, one's negative, and then the 2's are opposite signs. One's positive, one's negative. So what I could do is I can say it's a times b minus 2 over, I can factor out a negative 1, and then this becomes b minus 2. Now I've got the same factor in the numerator and denominator, so I can knock that off. And then a divided by negative 1 is just negative a. So I simplified that entire expression down to just be negative a. So next up, I've got x to the fourth y minus 3x to the fourth over 3x cubed minus x cubed y. So in the numerator, I can factor out an x to the fourth, and I'm left with y minus 3. Over in the denominator, I can factor out an x cubed, and I'm left with 3 minus y. I've got x to the fourth on top and x cubed on bottom, so I can simplify the numerator to just be x and the denominator to go away. So I've got x over y minus 3 over, I'm going to rearrange my denominator to make it negative y plus 3. So looking at these, my y's are opposite signs, my 3's are opposite signs, so I can factor out a negative 1 out of the denominator or the numerator, it doesn't matter which one, to get them to be the same. So x times y minus 3 over, I'm going to factor out a negative 1. And then that's times y minus 3. Got a y minus 3 in the top and the bottom, so I can simplify that out. So I get x over negative 1, which is just negative x. Okay, multiplying. You simplify as much as you can. factor as much as you can, and then combine like terms. Well, not combine like terms, but you just put it all together. You're still only looking at the denominator to see what the restricted values are.